Valve just announced the Steam Machine is back with a rumored price between $700 and $800. Now everyone is asking, should I just build my own PC instead? I matched every single component in the Steam Machine with real PC components so we can compare what is best to buy. And the answer might just surprise you. Spoiler, building it yourself right now might just cost you more. Firstly, here's exactly what is in the Steam Machine so we know what we have to compare it to. These are all based on Valve's official specs. For the CPU, we have a custom AMD Zen 4 processor. It has 6 cores, 12 threads, and up to 4.8 GHz boost clock with a 30-watt TDP. It's quite impressive really. Think of it as a downclock Ryzen 5 7600. For the GPU, we have a custom AMD RDNA 3 graphics. It has 28 compute units and running at a sustained max clock speed of 2.55 GHz. Holding 110 watts with 8 GB of GDDR6 VRAM. Performance is very similar to a desktop RX 7600 or an RTX 4060. For memory, we have 16 GB of DDR5 RAM. Storage comes in two options, either 512 GB or 2 TB of SSD. Both are expandable via microSD. As for connectivity, it has Wi-Fi 6E, Bluetooth 5.3, and Gigabit Ethernet built in. As for the ports, we have one single DisplayPort version 1.4 supporting 4K at 240 Hz. In addition, we have one HDMI 2.0 supporting 4K at 120 Hz, and we have one USB-C 3.2 Gen 2. We have two USB-A 3.2 Gen 1 and two USB-A 2.0 ports. In addition to all of this, it also supports FreeSync, so if your TV has it, you can use that. And it also has RGB lighting because of course it does. And that's the full package. Now let's see what it costs to build this yourselves. Let's start with just looking at the CPU. The Steam Machine uses that custom Zen 4 chip with 6 cores, 12 threads, 4.8 GHz of boost. For a do-it-yourself build, I looked at 3 Intel options in the same performance range. I don't have any Intel bias, they just happen to be on sale when I looked up the prices. First option, Intel i3 14100F at $97 from Amazon. This is only a 4-core chip that underperforms the Steam Machine, so it'll handle gaming, but you're leaving some performance on the table. The next option is the Intel i5 14400F, coming in at $156 from Newegg. This one slightly underperforms the Steam Machine in gaming, but it actually beats it in productivity workloads. Lastly, and our third option is the i5 14600KF, coming in at $166 from Amazon. This one outperforms the Steam Machine across the board, gaming and productivity. For this build, I'm going with the i5 14400F, coming in at $156. It's the sweet spot, close enough in gaming performance while giving you better productivity capabilities if you do need them. So for the CPU, we're writing down $156. Next up, the GPU. Valve's custom RDNA 3 chip with 28 compute units, 2.45 GHz sustained clock speed, and 110 watts, 8 GB of VRAM. This performs very similar to a desktop RX 7600 or an RTX 4060. For our do-it-yourself build, I'm using the Intel Arc B580, coming in at just $249 both from Amazon and B&H Photo, since I was lucky enough that he had it available at MSRP. This card both delivers better performance compared to the Steam Machine's GPU and comes in at a competitive price point. In some games it trades blows with the RX 7600 and in others it even pulls ahead. So for GPU we're gonna list down $249. Now for all the supporting components. So for the motherboard we need Wi-Fi 6E in order to match the Steam Machine's connectivity. That's about $130 for a board with integrated Wi-Fi 6E. For RAM we need 16 GB of DDR5. And here's where things get expensive. RAM prices have doubled in the last month. So right now, just 2 sticks of DDR5 RAM, each having 8 GB, cost a total of $175. And that's even for the relatively slow speeds. This is a critical context, because Valve likely locked in their RAM prices before they increased, so they can get it much cheaper than we can. So for RAM, we're gonna list down $175. Next up is storage. Here we have two options. The first option is 512 GB, and the second option is 2 TB. 512 GB cost about $50 and 2 TB cost about $115. In this comparison, I'll calculate both of them. For the PSU, we need to buy 500 watts. This will cost us about $65 for a bronze efficiency PSU. As for the case, we can get a decent budget case with somewhat decent airflow for about $45. As for the CPU cooler, we can get away with just having a tower cooler with a single fan. It's gonna cost us about $15. Let me add all of this up for us. And here's the final tally. So for the 512 GB build, it's gonna cost us $885. And for the 2 TB build, it's gonna cost us $960. And the Steam Machine is rumored to be about $700 for the 512GB version and about $800 for the 2TB version. So right now you'd actually pay more to build it yourself. You would be paying $185 more for the 512GB version and $150 more for the 2TB version. And on top of this, I haven't even calculated the price of the operating system. If you want Windows 11, you're gonna have to shell out an additional $100 to $140. The Steam Machine runs SteamOS for free. So the more real comparison with Windows 11, it will be about $1,000 for the 512GB version and about $1,075 for the 2TB version. Whereas the Steam Machine is only $700 to $800. That's an additional $285 to $325, all in Valve's favor. So, how come Valve can build it so much cheaper than you can buy it? There are 3 reasons. Reason number 1, economics of scale. Valve is ordering thousands of custom chips, motherboards and cases, so they are getting bulk discounts that you just can't get as a single individual. When you buy one chip for $156, they're buying 10,000 of chips for maybe $80 each. Same goes on for every component. Reason number 2, custom integration. That motherboard case and cooling solution are designed specifically for the Steam Machine. There's no wasted space, no over-spec power supply, and there's no RGB tags on every component. It's optimized for cost and thermal efficiency. And lastly, the 3rd reason, they locked in the RAM prices months ago. Remember how I said that RAM prices doubled in the last month? Valve likely placed their orders months ago. So at most they're paying maybe $90, probably even less. Now this does mean that Valve might have to raise their prices in the future, if the RAM prices either stay this elevated or if they go even higher. And here's the business reality for Valve. Valve cannot sell this at a loss. Unlike PlayStation or Xbox, which both subsidize their hardware and make money from the game sales, Steam Machine users might not buy any games for it at all. They could also use other platforms for getting the games. They could use Epic or Good Old Games, or they could use emulators or free-to-play games. So Valve cannot guarantee that they make back their money from the hardware. That means that $700 to $800 is likely Valve's break-even price, where they make just a small profit. So, is the Steam Machine worth $700 to $800? You should buy the Steam Machine if you want a plug-and-play living room machine without the hassle of building it yourself. You value the small form factor. You don't want to deal with Windows licenses or any weird updates. You want FreeSync support and all the Wi-Fi built in. You care about warranty and support. Valve handles everything if something breaks. Now, there are still good reasons to build your own PC. If you want maximum upgradability, if you need specific component choices, you already have some parts lying around, you have a higher budget and are willing to spend significantly more to get more performance, or you need Windows for some specific reason. My verdict, for most people who want a living room gaming PC without all the hassle, the Steam Machine at just $700 to $800 comes in at a great price. You're not overpaying for anything, instead you're getting bulk discount, and you're getting custom integration that you can't replicate on your own. But if you're an enthusiast that values the upgradability and customization, building your own PC still makes sense. Just know that you'll be paying a premium for that. All of the components that I mentioned are listed in the links below. I've also included affiliate links. If you use them, it helps support the channel. Do you want to build your own gaming PC with data-driven part recommendation? Check out MaxMyBuild.com. It takes your budget, use case, and preferences, then handles compatibility and budget allocation automatically. It uses aggregated public benchmarks and near-life prices to find the best performance per dollar. No guesswork, just data. If you found this breakdown helpful, remember to hit that subscribe button. I'll break down the numbers for you so you don't have to.